Alright guys, so for number 13, they ask us to kind of look at these different graphs. I was going to show them to you on the screen of my son's iPad, but he's dropped it a few more times, and the cracks it was hard to tell what the curve was and what a crack was in the screen. So unfortunately I had to redraw it, so it's not as fancy as it is in the book, but we'll do the best we can, right? Okay, so I want to look at number 13, okay? And what 13 says is this. It says, okay, let's investigate the parts of the equation, okay? And they tell us that the equation in general looks like this. The equation for curves like this, or an exponential curve, looks like this. Y equals a times b to the x. That's in general, that's how it works. Y equals a times b to the x. So if we look at these 6 curves, and they go A, B, C, D, E, F. They say, okay, well, let's concentrate first on the b value. Let's look at the b value real quick. They say which of these curves let's look at the ones that are increasing, and then we'll write down the b values for the ones that are increasing. And the ones that are increasing, so like as we move like from left to right, they kind of go up. So looks like that one's increasing. So A is increasing, and it has a b value of 2. I'm going to write this on the other page here. So increasing was A, and it had a b value of 2. The other one that was increasing looks like E. E is increasing right here. It has a b value of 1.4. So E is increasing, has a b value of 1.4. And then F was increasing, has a b value of, looks like 4. So F has a b value of 4. So if we look at those 3 values, 2, 1.4, and 4, what do they all have in common? It's kind of hard to tell right now because they're all positive. They're all more than 1, maybe. I don't know. Let's look at the ones that are decreasing first. So let's look at now at the ones that are decreasing. It looks like this one's decreasing. As we go left to right, it goes down. And the b value there is, so it's b. So b is decreasing, and it's got a b value of 0.25. 0.25. And looks like this one's decreasing, as C has a b value of 0.6. So C has a b value of 0.6. So now we look. And it looks like the increasing ones, these top 3, have b values that are, I think that's how it works, more than 1. And these decreasing ones, they're like kind of fractions, kind of between 0 and 1. And that's how that works. Let's write this down as a kind of as a rule here, okay? If the b value, if b is greater than 1, okay? So if b is more than 1, then we have what's called, then it's increasing, and that's called exponential growth. So that means exponential growth. All right. And then the other one is if b is less than 1, that's kind of what's going on here with these fractions, where it's like 0.25 and 0.6. The way I like to say it, though, instead of being less than 1, because that kind of opens up all the negative values and stuff, and I don't like going that far. So I'm going to say that b is like between 0 and 1. So I'm going to change it to look like this. So b is greater than 0, but less than 1. Between 0 and 1, then that's called, those are the ones that were decreasing, and that's called exponential decay. So exponential growth is when b is greater than 1. Exponential decay happens when b is between 0 and 1. Okay. There was one more situation that we had, and that was graph D right here, and it goes straight across. And that happened when b was equal to 1. Well, it was 1.0, but it was 1. And so when b is equal to 1, we say that it's constant. As we move from left to right, the graph stays exactly the same. So when the value of x is here, that's the value. When the value of x is here, that's the value. Value of x is here, that's the value. So every value of x has the same value for y. So that's why we call it constant. So when b is equal to 1, it's constant. Okay. Now let's take a look at what's going on with the A value. The A value, I like looking at C, D, and E. If you look at both of these three, you notice they all have an A value of 10, 10, 10, and 10. And then look at where the graph starts. So where it starts on the y-axis. Here it starts here, here it starts here, here it starts here. If you look, they all start at about the same spot. Where the graph begins on the y-axis is about the same place. And that's what the A value is. A is like the y-intercept. Where does the graph start? What the initial value was. Right? So if you look at C, D, and E, so if you look at graph C, D, and E, C, D, and E, A was equal to 10. All right, and that's another way we say it's the y-intercept. Or remember, we also call that the initial value. The initial value. And remember, the initial value happened whenever x equals 0. And I want to show you real fast how that works, when x equals 0 that happens. Let's just do a general equation. Y equals a times b to the x. Okay, we'll plug in 0 for x, and we get y equals a times b to the 0. Well, b to the 0, there's a rule in algebra. Anything to the power 0, except for 0. But any other number besides 0, if you use that number to the power of 0, it equals 1. There's a way to prove that, and we can do that if you want to later. But b to the 0, any number to the 0 is always 1. So y equals a times 1. So y is a. Whenever x is equal to 0, y just becomes equal to a. That's similar to in the linear equations when y equals a plus bx. If the slope, if x was 0, so you plugged in 0 for x, and so the car was 0 years old or whatever it was, or you had a 0-inch forearm, then you got your predicted height or predicted age of your car. In this case, we're plugging in 0 for x again, and this time we're getting our a value back again, and that's just kind of a different way to write it. Remember, the linear one was y equals a plus bx. And so here there was like a multiplication and then addition. Here there's an exponent and then multiplication. So just a little bit of seeing what's going on there. When x is 0, that's when we get our initial value. Okay, there's a table on top of page 212 that summarizes this pretty good. So take a look at the table, little things you need to know on top of 212, and then we should be good to go. All right.